All right, so welcome to our first day of notes. And so today we're going to be talking about congruent and adjacent angles. And so we're first just going to start off with defining some of these words. So, and I'll try my best to use this program for us. So adjacent angles, we kind of talked about this in class already. Some of this might be review for most of you, which is fine. And so adjacent angles, so these are angles that have a common vertex and a common side. And so I'll draw a little example for us in a moment. But most of the angles, especially last class when we dealt with the angle addition postulate, which I'll remind us of in a second, dealt with these adjacent angles. So in this case here, we have this little drawing. And so obviously you guys can press pause whenever you'd like to catch up and draw these images here. But in this case, I'm drawing an example here of an adjacent, or two adjacent angles. So in this case, my angle A, D, and B, so angle A, D, and B, so this angle is adjacent, and I'm just going to use abbreviation, is adjacent to angle B, D, C. And as you can tell by our definition, what these two angles share is they share a vertex. In this case, our vertex is D, right? Vertex is D. And the common side is this ray here, which is ray DB. And if we remember using our notation, we just put that ray notation above it. So these are the two things that we need to make something adjacent when dealing with angles. Okay? So this, like I said, will be what we use most of the time in this class. Now, we will have instances where they're not adjacent, and we'll talk more about those later. So just as a little refresher of what we talked about last class, the angle addition postulate, which is very similar to the segment addition postulate, they actually both come from around the same sort of meaning. And so the angle addition postulate, and this is just sort of a refresher, so refresh. What this tells us is that two parts of a full angle added together equal that whole angle. And so for an example, ooh, that's a really bad picture. Let me redraw that. Okay. So if we had this drawing here, let's say these are my angles, and we had like W, X, Y, and Z, my angle addition postulate would just say that, oh, angle W, X, Y, which is right here, plus my other angle here, which you could name as angle YXZ. These add together to equal the whole angle, right? So this would be my whole angle, which is WXZ. Good. And so the main property as to why we use this is this allows us to solve for missing angle measures. Obviously, this is very useful. We'll be using this throughout the year, especially in this little mini unit on angle relations, which we're going to work towards this week. And so this is our angle addition postulate, and we've shown plenty of examples there. So if you are confused with this, I would definitely either look at our notes from the other day or on your homework from the other night. So moving on from here, we're going to quickly mention two more things that you guys need to know for today in order to complete your different stations. And so these two things are congruent angles and an angle bisector. And so I'll go fairly quickly through a congruent angles. Overall, congruent angles are pretty easy. These are two angles that have the same measure. Okay, so these are two that have the same measure, meaning they're equal, right? And so you can just write this below here. So these are two angles that have the same measure. Now, as a quick reminder for us, this is our notation for when something is congruent. So this is our notation. So if I was saying that like angle 1 and angle 2 are congruent, just in general, I would put that there. But I can't use congruency when I'm calling two algebraic expressions equal. So if I had like 3x plus 2 and 5x minus 3, I can't say those are congruent. That's wrong. I would say that these two here are equal. So just keep that in mind in terms of, especially next unit when we start getting into proofs. This will be a very important difference between the two. And so, as well as when you see two angles that are congruent, so without me putting too much effort into labeling these, if these two angles are congruent, you'll see the similar overarching arch here. So if you ever see something like this, that means those two are the same. If you saw that this one had 2 slashes and this one had 1, it'd mean those are two different angles. So just be careful about that. All right, so on to the last thing, which we didn't talk about last class, and this is probably the newest thing for us today, is an angle bisector. If I can spell. So our angle bisector is very important. And so we sort of mentioned this word of bisector before. And so bi meaning two and sector meaning part of. And so what this does for us is it cuts an angle into two congruent pieces. And here's that word congruent again, meaning it cuts our angle into two, remember two bi, and congruent pieces being sector, okay? So if I drew a little example here like before, here's our same drawing. I probably should have just kept the same drawing for this entire thing, but here's our drawing. We have A, we have B, we have C, and we have D. And so if BC, right, ray BC, or our side, let me fix that real quick. So if we have BC, ray BC, if it states that this is an angle bisector, this tells me now that it splits this full angle. So it splits angle ABD into two equal parts, meaning that angle ABC is congruent to angle CBD. Okay? So this is the most important thing. We did an example like this in class the other day. So if this was like 5x and this was like 2x minus 7, I would set these two equal to each other. I wouldn't say 5x is congruent to 2x minus 7. I'd say 5x equals 2x minus 7. And I'd solve from there.